Okay, good afternoon. Good afternoon, everyone.
Good afternoon, sir.
Yes, good afternoon. Okay, shall we start the session? Mm, for today's class, I request um, 4 people to join with us, and Ajay, Anand Bodi, Archit Naik, and Ashwata. Please join with us. First of all, Ajay, Anand Modi, Archit Naik, Ashwat and I request Bhavya to join with us. Bhavya, please.
Yes, sir.
Good. Have you solved the yesterday assignments? May I know the results of those problems? Later we will take the attendance. Uh, now friends are joining. Around 21 persons are in the meeting. Sai Ganesh, what happened for the problem which was given to you? That is bisection method. How you solved Sai Ganesh? We have requested to solve manually, that is iteration number 1, 2. In such a way, we have requested Sai Ganesh to solve. Anyway, as per the iterations, various iterations you need to solve during your examinations. What we are presenting in the PPT is not a way to present during your examination, and in this way you won't present during examination. It won't be the right way. And present the iteration number 1 and find f of a. Let a is equal 0, b is equal your c is equal 0.25. Then find your f of a and f of b. Then based on that you slowly find various iteration results, and at the end of 5th or 6th iteration your C is your required result. So in the regular falsy method, in order to know basic idea about the regular falsy method, we have already aware about the similarities of two triangles. Here, we will solve the equation for the regular falsy method. Assume this is the line which crosses this the way. Are you able to see the presentation, Anand Modi?
Yes, sir.
Yes, sir.
You're able to
Yes,
see.
good. Bhavya, have you joined?
Yes, sir. I've joined, sir. I'm
Yes,
sorry I
very good.
was late.
Okay. And the new is our solution region. New is our expected result. And assume this is a triangle, and this point is the cross section, the where the changes occurs when negative to positive or positive to negative occurs. That is the required point of solution. And here assume this is the point B, and this is f of B, and this is A and f of A. Assume this triangle, that is A, C and f of A, and B, C and f of B. In that f of B divided by C minus D. C minus D is equal to f of A divided by C minus A. From that, by doing cross multiplication, the C minus A into f of B is equal to C minus D into f of A, and dividing, getting the C on one side, that is C into f of B minus A into f of B is equal to C into f of A minus B into f of A we get, and accumulate C on the one side, and CF of B minus CF of A will come this side, and the AF of B goes on the right side, and getting C out of these two, and we'll get f of B minus f of A. On the RHS we have f of So A f of B minus B f of A, and having C on one side, we'll get A f of B minus B f of A divided by f of B minus f of A. This is the required formula to solve using regular Falsi method, and that was we did yesterday, and problem we have solved yesterday, that is x cube minus 2x minus 5 is equal to 0. We found the results with two digit accuracy, and this problem we have requested, I think yesterday we have solved this problem. Bhavya, we have solved this problem yesterday.
So you sent the solution to us.
Yes, sir.
Yes, I have requested problem number 17 and 18 to make a note, and I have given one homework also, that is assignment also. This I think you have solved problem number 17, and you will get with 3 decimal places we will get the results, that is 2.789. And concerning problem number 18, and we here there is no in particular to this problem number 17, the results, the zone has given by the problem itself, that is x0 and x1. We need to consider this as A and B. Whatever may be the symbol assigned in the question paper, we need to take as we have studied. Here we have studied A and B, isn't it? And take 2.5 as an A and 3 as an B. And concerning to the solution, find here the iteration 1 has 2.8013. In the last problem, that is in problem number 16, what we have found in iteration 1, we are getting the function of the results is in negative. Therefore, the roots may lies between 2.058 and which we have derived, and 3. The 3 is the upper zone, 2 is the lower zone. The lower zone shifted to 2.05. The lower solution region is now shifted to 2.05. But here in the case of problem number 17, what happened? The lower boundary is 2.5 and the upper boundary is 3. The upper boundary becomes 2.8. See here, the result is 2.8013, and you are getting a positive value. And be aware, here we are getting positive value. The solution region must occur between negative to positive. Therefore, the upper boundary, we need to switch the upper boundary from 3 to 2.8. That is the thing we need to consider during solving problem number 17. Isn't it? It is clear. Similarly, for iteration 2, iteration 2 also we are getting a positive value. Therefore, don't change your lower boundary. We need to worry about the upper boundary. Upper boundary, we have earlier we have considered the positive results we have obtained through the upper boundary. Therefore, here also we need to worry about the upper boundary. We need to switch the upper boundary from 2.8 to 2.79. Therefore, here we are while in the third iteration you will get the f of 2.7984 into 0.0040. While concerning about the 4 decimal places, this is not seems to 0. This but while using the calculator the 4-digit accuracy, we will get 0.0000, and therefore the root lies the required root is 2.7984. Have you cleared? The boundary, switches of boundary is very essential. Do you have any doubts in this particular problem? Now in this problem we are switching the upper boundary. Are you clear with the problem?
Yes, sir.
Yes, sir.
Ajay, please. Ashokram, please.
Sir, Ajay's mic is not working. He's not able to turn it on. He's written on the chat group.
Okay. Good. Okay. In concerning the problem number 18, in the problem there won't be any boundaries given in the problem. Therefore, we need to find the appropriate boundaries. We need to find the boundaries. Therefore, here, as I have solved f of you start with 0, 0, 1, 2, 3. So in that way, you need to start. Here, f of 0, you will get the mathematical error, and f of 1 becomes a negative value, and f of 2 is also negative. And concerning f of 3, you will get a positive value. Therefore, the root lies between 2 and 3. Therefore, we need to apply the appropriate values, that is a, b, f of a, and f of b. We'll get the results 2.721 in iteration 1, and iteration 2 you will get 2.7402, and in iteration 3 you will get 2.7404, and the required root is 2.7406. And this is the problem which I have given for you to practice. And any findings? What was the comparison? What was the inference from doing Newton-Raphson method? Newton-Raphson and regular-Walsey method.
Both were, it was correct only. Like both got same, like regular
Both we
false
get-
and
Yes, I think this is Asutram. Asutram, who is talking?
Nishant sir.
Nishant. Tell me, Nishant. Very good, Nishant.
Regular falsy I got between 1.3685 and 2.
And 2, okay, good. And
Newton's method I got 1.3688.
okay, both can get similar results.
Yeah.
By using both methods, we are okay. Any other inference?
Sir, it took more iterations for regular falsy than.
Very good, very good. Who is this?
Sir Anand.
Anand. Who is this?
Anand, sir.
Anand, very good, Anand. The convergence rate of Newton-Raphson method is quite better than the convergence rate of regular false method. That inference we can apply by solving this method, this particular problem. See, this is your problem number 19, and this solution. Coming to concerning the iteration number 1, we will get 411 Newton's method, and 437 in regular falsy, and 2 similarly 2, 3, 4. In 4 you will get 3688. Here 3688. The 3688 can be achieved even in the iteration 3 itself in Newton-Raphson method. Therefore, the inference of this particular problem is the Newton-Raphson method converges faster than the regular falsy method. Okay, those who have not solved the problem, please make a note with the presentation, and I have we will see unit 4 from now onwards. There are some other portions is also available in unit 3, that is iteration method. We have to concern about iteration method in unit 3. That is iteration Newton forward interpolation methods. There are plenty of informations we need to discuss with unit 3. We need to concern about Newton forward interpolation, Newton backward interpolation, central differences, and Gauss forward and backward interpolation, Stirling formula, and Bessel's formula, Laplace. There are various properties of the operators that we have to solve. And concerning the numerical differentiation integration, and we need to have a visit over the trapezoidal rule, Simpson 1/3 rule, and truncation error in trapezoidal and Simpson rule, and there are other topics also available in numerical differentiation and integration. And now we will concern about unit 4. Once our unit 4 is over, then we will revisit the interpolation and numerical differentiation and integration, which is available in unit 3. So far we have solved iteration method, bisection method, and Newton-Raphson method in unit 3. That is half of the portion we have completed in unit 3. The half of the portion, that is interpolation, and the numerical differentiation integration is left. That once the unit 4 is over, then we will revisit the interpolation and the other half, that is interpolation numerical differentiation integration. Today we will start unit 4. Up to this point, that is this is the exercise for you to practice in regular falsy method, and up to this point I have and one more thing, some authors may use a different formula for regular falsy method. This is the formula. Some authors may use this type of formula also for finding the results in regular falsy method, that is xn plus 1 is equal to xn, that is here x3 is equal to x2 minus x1 divided by f of x2 minus f of x1 into f of x2. This is the way also they will some authors will solve the regular falsy method. And up to this point I have disseminated the material in our MS team. You can find the PPTs which we have disseminated in unit 3. Okay, now we'll start initial value problem and boundary values problem, that is our unit 4. So far we have completed 1.5 units. We have completed unit 2, and half of the unit half of the portions in unit 3 we have completed. Now we will concern about unit 4, which describes the solution of initial value problem and boundary value problems. Make a note that let the second order ordinary differential equation be in the given form, and in this particular unit we are going to get the solution for various differential equation, that may be ordinary differential equation or it may be a partial differential equation. This is what we are going to solve in unit 4. We are going to get the solution for differential equation, that may be an ordinary differential equation or it may be a partial differential equation. And please make a note that this is the form usually the differential equation can be written, that is d square y by dx square plus a constant, that is a1 into dy by dx plus a constant, that is a2 into y, is equal to f of x. And this d square y by dx can be written as dy by dx can be written as d. Therefore I am coming from left, f of x, let it be f of x, and this term a2 into y of x, and y is in terms of x, y is independent of x, and a1 into d, this can be rewritten as d of d differentiation, that is d y of x, and a1, and here we are doing 2 times, therefore it can be written as d square y of x, and even this can be rewritten in the form of y double dash of x plus a1 y dash of x plus a2 into y of x is equal to f of x. And if this can be simply written as y double dash plus a1 y dash plus y is equal to y f of x. This is the various form of the usage of differential equations, and the partial differential equation can be written in the form as described, as picturized in the presentation, that is a xy dou square u by dou x square plus b in terms of xy, that is dou square u by dou x dou y plus c dou square u by dou square y plus a function. This partial differential equation may be linear or a non-linear, that depends on the functions which given in the problem, and the term which is associated with a is termed as the term which is associated with dou square u by dou x square is a, and dou square u by dou x dou y is termed as b, and the term which is associated with dou square u by dou square y is termed as c. Based on this terms, that is a, b and c, we need to correlate with the basic quadratic equation, that is ax square plus bx plus c is equal to 0. From that we need to apply the A, B, C value in order to find whether it belongs to less than 0, or it is equal to 0, or it is greater than 0. Already we are aware about the elliptical, probability, and parabolic and hyperbolic functions. If the b square minus 4ac is less than 0, that is elliptical equation. B square minus 4ac is equal to 0, that is equivalent to, that is parabolic, and if it is greater than 0, that is hyperbolic. And in this particular unit, we are going to solve all elliptical, parabolic, and hyperbolic equation, whether it maybe belongs to an ordinary differential equation, or it may be a partial differential equation. And these are some key points which we are going to see in this unit is. And if it is less than 0, that is elliptic. If it is equal to 0, that is parabolic. If it is greater than 0, that is hyperbolic. That is dou square u by dou x square plus dou square u by dou y square is equal to 0. And this is the general form. By applying various a, b, c value in the b square minus 4ac, we will get lesser value, less than 0. This can be rewritten as uxx plus uyy is equal to 0. That is why we are differentiating y we are differentiating u with respect to y 2 times, and we are differentiating u with respect to x 2 times. Therefore, that is written as xx. Here u yy is equal to 0. Then that type of equation classified as elliptical. And there are two ways of getting this solution. If it is 0, the RHS is equal to 0, that can be classified as Laplace equation. That can be classified as Laplace equation. And if we have the RHS, that is, we have a function on the RHS, then that is classified as Poisson's equation. Therefore, under elliptic, we are going to concern about Laplace equation and Poisson equation. In parabolic, if it is equal to 0, that is dou square u by dou x square is equal to a into dou u by dou t. Dou square u by dou x square is equal to a into dou u by dou t. Here, the heat flow equations can be classified as parabolic equations. The heat flow problems can be solved with the help of these parabolic functions. And under this, we have 3 different categories. One is Schmidt, and Bender-Schmidt, and Crank-Nicolson. We are going to visit over 3 topics under parabolic, that is Schmidt, Bender-Schmidt, and Crank-Nicolson. And concerning about the wave equation can be classified into hyperbolic, that is greater than 0. If the b square minus 4ac is greater than 0, then that is called hyperbolic. The form dou square u by dou x square is equal to a into dou square u by dou t can be these equations can be written in the form of ax square plus bx plus c is equal to 0, means we will get b square minus 4ac is greater than 0. Then therefore these equations can be categorized under hyperbolic. The wave equations are examples for hyperbolic, and this is what we are going to have a visit in unit 4. And please have a note over this equation. If dou square, that is uxx plus uy is equal to 0, that is elliptic. Uxx is equal to a into ut, then that is parabolic. Uxx is equal to a into u double t. Here ut, the u differentiated one time with respect to t, and here double time. Therefore, uxx is equal to uat, and the difference between hyperbolic and parabolic is here ux is equal to a into ut. Here uxx is equal to a into u double t. This is the difference, and this is what we are going to solve during the unit 4. And this is your exercise number 1a. First, we will find whether the given equation is belongs to elliptic or parabolic or hyperbolic. That we will have a visit, and then we will solve the given problem. And assume this is the given problem, that is x square xx plus 1 minus y square into fyy is equal to 0. For the y, if it is the y varies from -1 to 1 and x varies from minus infinite to infinite, and we need to find the given problem is belongs to elliptic, parabolic, or hyperbolic. and compare this with a given equation. These are equations, that is a fxx plus b fxy plus c fyy. This is what we have here. Both are similar. There is no more difference between ordinary. Here ordinary, the differentiation is ordinary. Here the differentiation is partial, and here therefore a f xx plus b f xy plus c f xy. By comparing these two, our x is equal to a is equal to x square. Here b doesn't have any terms combining xy. Therefore b is equal to 0, and c is equal to our 1 minus the term which is associated with fyy is c 1 minus y square. Therefore applying the above values into the equation, that is b square minus 4ac will get minus 4 x square into 1 minus y square. By rearranging the above equation, and we'll get 4x square into y square minus 1. Now consider the given boundary. Given boundary, that is x square is always positive, whether it may be ranges from minus infinite to infinite, because we have power 2, therefore it is always positive. But in the case of y, when it changes from minus 1 to 1, what happens? Assume we are applying a 0.5 or a minus 0.5. The number in the y square becomes a lesser number than 1, and it is always negative. Therefore this becomes positive and this term becomes negative. Therefore we are getting a negative value for multiplying these two. Therefore the b square minus 4ac is always negative. Therefore the equation is belongs to elliptic. It is clear. Ashwatram, shall we continue? Arvind Roshan.
Yes, sir.
Shall we continue?
Yes, sir. It's clear.
It is clear?
Yes, sir.
Okay. Now this is exercise number 1b, and fxx plus fyy is equal to 0. If x is always greater than 0 and y is always greater than 0, then we need to find whether it belongs to elliptic, parabolic or hyperbolic. Here the term x belongs to a, and our c is equal to y, and we don't have term which is associated with fxy. Therefore b is equal to 0. By applying these things, we'll get a negative value. Therefore this equation is also belongs to elliptic equation. And concerning this equation, that is fxx minus 2 fxy is equal to 0. X is always greater than 0 and y is always greater than 0. The coefficient which is associated with the fxx is 1, and the coefficient which is associated with the fxy is equal to minus 2, and we don't have a term which is associated with the fxy. Therefore that is c is equal to 0. By applying these terms into b square minus 4ac, we will get a positive number, that is 4. It is greater than 0. Therefore it is classified as hyperbolic function. And this is your exercise number 1d, and uxx minus 2 uxy. We have all the terms, that is uxx, uxy and uyy, and 1 minus 2, 1 are the coefficients, and we will get 0. Therefore it belongs to a parabolic. And 1d, fxx, some others use the function f, or some others use u. Don't worry about the symbols. The concept is very essential. Fxx plus 2 fxy plus 4 fyy is equal to 0. The x and y is always greater than 0, and a is equal to 1, b is equal to 2, and c is equal to 4, and b square minus 4 is equal to, we'll get a negative value, that's minus 12, which is less than 0. Therefore the given equation belongs to elliptic equation. Okay. Elliptic equation can be solved with two different formulas, standard 5-point formula and diagonal 5-point formula. And before having a visit over this standard 5-point formula and 5-point formula will take attendance. And okay, I have attendance. I'll don't worry about your attendance. Don't if I am seeking someone, then you respond. One, I think one is not present. Abhishek Chapatikar. Okay, one is absent. I will take attendance. Don't worry. No need to respond. When I am seeking someone, then they can alone give your presence. 3 is present. 6. Amula Shrikant. Amula is absent. Anand Modi is present. And number 11, Jai Singh is present.
Present, sir.
Yes. I'll take present. Roshan is also present. Ashwatram present. Bhavya is present. Kalyan, please. Kalyan is absent. Okay, Chita is present. Gaudam is also present. Ajay is also present. Campbell Komal is also present. Maharaja present. Maharaja present. Marikanti Ashwini present. Afsal is also present. Archit Naik is also present. Kaushik, Nauro Kaushik. Please give your attendance. Nauro Kaushik is absent. Nirmal, okay, no name Nirmal. Present, I'll give present. Nishant also present. Pradeep present. Pravindra present. STD present. And yes, Rahul is present. Where is our 89? 89 is present. Where is Rahul Arya? 88. 8. Yes, fine. Okay, he's also present. Rangarajan present. Sabarnik was present. Saigan is okay. Samar Pratap.
Yes, sir.
Vikash Babu Mehta. Vikash, please give your attendance. Vikash. Malaysian, okay, good.
Sir.
Vikash, are you in line? Purna Chandra.
Yes, sir, I'm present.
Purna Chandra, please attend the class. Purna Chandra.
Yes,
Please
sir.
attend regularly. Yesterday
Okay.
and day before yesterday, I think you are absent. Please attend the class regularly.
Yes, sir. Thank you. Sir, I think my network problem is there. It's not showing the attendance in your monitor.
So then give me a message. Then give me during class hours. Give a message and present.
Okay, sir.
The representative will represent your presence.
Yes, sir.
Vikas Babu Mehta. Okay, concerning today's attendance, number 1, number 6, number 24, 71, and 117 is absent. If anyone present, please let me know, representatives. Okay, since it was an afternoon class, that is we are in 12:30 to 1:20, and if it is an class, yes, who is raising your hands? Rahul, I have given your attendance, Rahul. 88 I have given, right? And if it is an interactive class, that is in we are in NIT, Usually we'll discuss the information which is happening in and around us. What was the hot topic today? We'll have a visit and then we'll see numerical methods. What is the headlines in today's Hindu? Or anyone wish to have a
Yes, sir. Like the opposition parties were on a strike in the Parliament garden, sir.
Very good, very good. That is what we are needed. And why? For what reason they are?
There have been 6 MPs were suspended by the chairperson of the Parliament, sir.
Okay, and for what?
Sir, actually, they like literally they threw the book on the chairperson, sir, on the face. They fought with the chairperson on that day on a debate. There was a debate on that day based upon the like farmers, all those issues.
Yes, yes. New amendment bill over the agriculture issue, isn't it?
They released 6 amendment bills, sir.
Yes, yes. And please have an opinion. Please have an opinion that whether it is positive or negative. The amendment bills is encourageable, or it won't be necessary for doing amendments over the existing bill. And please have a idea about it. And if feasible, we'll discuss in subsequent classes. And please have a very good attention over the happenings which is happening around us. And any 1 or 2 points about the advantages or disadvantages over the bill, or anyone willing to share? Rahul is attentive. Any other vision over the amendments? Okay, okay. I think please have a attentiveness towards the happenings, and if time permits, we will discuss those things. Now we will concern about our PPT, and my appreciations, Rahul, that you are having attention over the happenings. Since if time permits, you are all in team now. You may spend your more time with IPL, isn't it? Rahul,
I didn't get, sir. What, sir?
What was your opinion about IPL?
IPL, sir. Like I stopped watching 3 years back, sir. Like.
Okay, okay. Yeah, in the IPL season, it is very hard to find the other informations from the team. Since you are belongs to team, you are giving the attention over the other happenings also. It is good, and my appreciations. And if time permits, we will discuss IPL too. Now, but we don't have the time, and we'll concern about numerical methods, and this is the standard 5-point formula, and we are going to find U, I, and J. My cursor is visible, Bhavya. My cursor is visible. My PPT.
Yes,
Over
sir.
the
Yes,
PPT.
sir.
My
Yes, sir.
yes. We are going to find Uij. We are going to find Uij, and assume this is a Cartesian coordinate, and this is positive I, and this is positive j. Then this becomes Ui plus 1 comma j. There is no change in j. Here Ui minus 1 comma j, and here Ui comma j plus 1 and Ui comma j minus 1. This is the standard 5-point formula. This based on this formula, that is Ui comma j is equal to 1 by 4, which is surrounded the Uij. That becomes the formula. That the addition over those things and the division by 4 becomes Ui comma j. And standard diagonal 5-point formula becomes as what we have seen in the earlier standard 5-point formula. It is very similar, that here Ui plus 1 comma j plus 1, here I minus 1 comma j plus 1, here both are minus. please merge these things with the Cartesian coordinate. That's all. It is very simple. U I minus 1 comma j minus 1. Here U I plus 1 comma j minus 1, and this is the accumulation of this four formula that will give U I plus 1 I comma U I comma j is equal to 1 by 4th of this four things. And now this is the Laplace equation, that is dou square u by dou x square plus dou square u by dou y square is equal to 0, and we assume that we are aware about the various boundaries. Assume this is the plate. The four boundaries we know, that is here, that is we know the horizontal lower portions of the horizontal, and we know the upper boundary, and similarly we know the leftmost boundary, we know the rightmost boundary, and assume we are concerned about the inner portions. We need to find the temperature, whether it may be our plate. Assume this is the plate. Our plate is exposed to the atmospheric, and some left or bottom portions maybe heat source, and what happened in the mid side we need to consider, and with that Laplace equation we can find the results. Assume the outer boundaries are known. Assume the outer boundaries are known, that is A1 and A2, A3, A4, A5 till A16 we know, and we need to find the various U, that is U1, U2, U3, U4, and till U9 we need to find. What we can do with the aid of standard 5-point formula and diagonal 5-point formula, we can find this various U's. Shall we start with U5, that is midpoint? In order to apply the standard 5-point formula, we need 4 boundaries. Assume U1. We are concerned about U1. We know 4 boundaries. Please reply me, Anand Modi, Arvind Roshan, Ashwath Ram, and Bhavya. If we are concerned about U1, and we are going to apply the standard 5-point formula, we can find U1. We know A16. We know A2. We know U2, and we know U4. Bhavya, Ashwath Ram, Arvind Roshan, Anand Modi. No one. I think no one. Kalyan answered. Yes.
Sir, I didn't get this, sir. Can you explain again?
We need to find U1.
Yes.
Based on the standard 5-point formula, it is feasible to find the values of U1. We'll revisit. We will revisit 5-point formula. See, standard 5-point formula, and the 4-point. This is the standard 5-point formula, and this is diagonal 5-point formula. And now we are concerned about U1. Apply any of the above formula to find U1. It is feasible.
Yes, sir. If we know A2,
Concern
A16, U2, and U4, we can find U1.
A little louder.
Sir, if we know A2, A16, U2, and U4, we can find U1 from standard 5-point.
Yes. Okay. Good. Apply your diagonal 5-point formula. If we know A1, A3, A5, and A15, isn't it? A1 diagonal. Assume diagonal. For U1, A1, A3, U5, and A15. But the thing is, we don't know the various values of U1. Therefore, what we are going to do, we are going to find the value of U5 based on this 4 boundaries, that is U15, A15, A3, A7, and A11. A15, A3, A7, and A11. If U5 is known, we can apply the diagonal 5-point formula for finding u1, u3, u7, and u9. Got it? See, I am. This is our u5. U5 we can find u5 by applying the standard 5-point formula a15, a7, a3, and a11. Now we know u5. See here, the u5 can be calculated with the aid of standard 5-point formula, but not using u4, u2, u6, and u8, because that is also unknown. And based on this a11, that is a15, a3, a7, a11, we can find our u5. Okay. Now concern about u1, u3, u7, and u9. By applying diagonal 5-point formula, we can find this u1, u3, u7, and u9. u1, we know here, we know a2, a5, a3, sorry, a1, a3, u5, and a15. Sir, why can't the standard 5-point formula? There may be a question rises. See, v6, we know a16. We know a2, but we don't know u2 and u4. Therefore, we are concerned about the diagonal 5-point formula for finding u1. We know a1 and we know a3. Now we have calculated u5. Already we know a15. Therefore, this u1, u3, u9, and u7 can be calculated with the help of diagonal 5-point formula. Is it fine? Is it understandable? u1, u3, u7, and u9 can be calculated with the help of diagonal 5-point formula. And now, see, you now concern about u2, u4, u6, and u8. This can be calculated with the help of standard 5-point formula, because 4 boundaries in the axis are known. Therefore, apply standard 5-point formula to calculate u2, u4, u6, and u8. You see, now concern about your u2, we know u1, already a3 we know. Now we have calculated u3, we have calculated u5 based on 4 boundaries which is lies on the axis. With that we can find u2. Similarly, we can find u4, u6, and u8. This is the way that we are going to solve the problem in ordinary differential equation and partial differential equation. Any doubts? Any doubts here? Do you have any doubts over the standard 5-point formula or diagonal 5-point formula?
No, sir.
No. Okay. Once we are familiar with standard 5-point and the 5-point formula and diagonal 5-point formula, then this is the Liebman's iteration process. Why we need Liebman's iteration process? This formula will visit while solving the problem. We will have revisit over the Liebman's formula. Why? What is the need to have such a formula? Liebman's iteration process, that while solving the problem we will revisit this page. It is similar to that of standard 5-point formula. The thing is, iteration is newer. We are going to apply the newer calculated term. That is an advancement over the Laplace standard 5-point formula. And this is problem number 2. That is exercise number 2. Please make a note. Tomorrow we will solve this problem. Please make a note now. Solve uxx plus uyy is equal to 0. If the x varies from 0 to 4 and 0 greater than or equal to x greater than or equal to 4. Similarly, 0 greater than or equal to y and greater than or equal to 4. And we have 4 different boundaries. That is, given that u0, y is equal to 0, u4, y is equal to 8 plus 2y, ux plus 0 is equal to x square by 2, ux, 4 is equal to x square, taking h and k is equal to 1. H and k. Otis and H and K will see. Obtain the results correct to 1 decimal. It is very easy because they are concerned about 1 decimal alone. Please make a note and we will solve this problem tomorrow. Do you have any doubts? So far, do you have any doubts in standard 5-point formula or diagonal 5-point formula?
No, sir.
I think there is no doubts. Okay, anyone joined after taking attendance? 1, 6, 24, 71, and 1 sir. Anyone joined?
One joined, sir. Roll number 1.
Okay, 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 good. Fine. Then, anyone? Okay, okay, fine, fine. Thank you, thank you, thank you. So tomorrow, next week we'll see. Next week we'll see. And I request the representative please stay with us. Others, you may leave this. Others, you may please leave this. Thank you for attending this class.
Thank you, sir.
Thank you, sir.
Yes. Anand Modi, Bhavya, and Rahul Sabranipal.
Yes, sir.
Yes, sir.
Yes, sir.
In the next week, I have commitment during Tuesday. It is feasible to arrange instead of taking the classes on Tuesday, we will arrange 1 hour in the present week itself. It is feasible.
Sir, Friday 11:30 slot is free for production B, but I don't know about production A.
Tell me, Rahul.
Sir, we have the class, sir.
Yes, sir.
Rahul and Bhavya.
So we have
So
class
mostly-
on Friday, sir.
Yes, please.
So mostly evenings are free.
Yeah, sir. Evenings are free.
Not for us, sir. We might have an MME class, so we can't really say.
Oh. Okay, please. Okay.
Sir, we'll let you know, sir. We'll discuss and
Okay,
let
please
you know.
have a conversation.
Yes, sir. Yes.
Sure, sir.
Yes, sir.
If it is prior, we are cancelling one particular class and arranging after cancelling it, it is not encourageable. And we are taking prior means it is well and good. And please try to arrange in this week. Then we will cancel Tuesday.
Sure, sir. Okay.
Yes, sir.
Sure, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yes. Thank you.